lead to a lot of that could lead to a manageable and maintainable code base on a long term. So with that, we'll move on to maintainability and modifiability. Once a product is built and out to the market, what's more important is to be able to find any issues, be able to troubleshoot the product itself very quickly. So that's about maintainability. Maintainability is about how faster or how easier is it to maintain your code base, right? One important aspect that you will have to keep in mind for your code to be maintainable is to have proper instrumentation. The proper instrumentation can help in troubleshooting very faster. So the common practices that are taken to have a better troubleshooting mechanism is to instrument enough data. So you need to have a proper instrumentation strategy which says what are the data that are going to be instrumented. It's just not an exception stat trace that is going to be enough. The data that led to the error should also be captured. Proper use of exceptions need to be in place. Have error handlers for specific type of errors. Not all errors have to go to the database. Not all errors need to go to event logs. So properly categorize your error types, and based on the error types, you could have different error handling strategy. You could also devise strategies like if there are certain errors logged in your system, it should notify so and so people. So if you have for example, showstoppers, you could, with severity very high, you could have an error handler that reports back the error using a notification to concerned people. So that could be an error handling strategy itself. And also properly devise where you are logging and have searchable logs. The formats of the error has to be proper. Use DB in case you are expecting to analyze the instrumentation data. And also, it's not just enough to instrument errors. If you are dealing with a system which has to provide a lot of high-end performance, then it's important to instrument performance-related data also. So instrumentation is the key for troubleshooting both error scenarios as well as performance scenarios. Coming to modifiability, once a code is written, it's definitely going to go through a lot of changes in terms of the change in business, change in functionality, and so on. So it's extremely important to write modifiable code. Otherwise, from a long-term perspective, changes that are going to be brought into the system are going to become extremely difficult. So in order for your code to be maintainable, these are the patterns that you can follow. Split the systems into subsystems. Instead of having a single monolithic system, please split the system into proper subsystem and make it modular. Draw the boundary of the modules very clearly. Adopt a framework-based approach. We'll be, in the later half of the session, we'll also be covering what a framework is and how it helps bringing quality to your application. Do not repeat code. Go for a centralized routine wherever you have a common need. Use high cohesion and low coupling. Adopt an object-oriented programming approach because that brings in a lot of maintainability. Use interface-based design, and this is a common practice that you could follow. Have implementations outside and always depend on interfaces to communicate between two modules or two classes, so that changes in one place does not affect the change on the other classes. Use abstraction wherever the implementation could undergo changes. Adopt MVC architecture. So architectures like MVC helps a great deal in separation of concern. Adopt service-oriented architecture. So service-oriented architecture inherently brings reusability within an enterprise. You don't have to reinvent logic in a lot of different places. Hence, adopt SOA-based architecture. Adopt inversion of control pattern and AOP for common tasks. For example, AOP can be used wherever you are instrumenting, wherever you are catching exceptions, and so on. Adopt patterns like chain of responsibility, command pattern, and unit of work pattern, which splits a single monolithic task to multiple subtasks and perform. Again, from coding practices, keep the code simple, have sufficient commenting, use proper naming standards, write testable code, and it's very important that we write testable code because it's easy to unit test, and have mock objects wherever required. Restrict the number of lines to lesser than 50. Take static messages outside and make it configurable, because one common requirement or one common change that happens in a product is for the display messages to be different, right? So it's better that we have that outside externalized so that the code needs not be touched every time. And monitor and properly tune and maintain cyclometric complexity. Do not hard put static values. Have either